Material requirements. Now that we have defined a material master and understand how it's connected to the larger organizational ecosystem through proper integration, the next critical phase of the materials management lifecycle is collecting the precise material requirements. During this phase, the engineering drawings, specifications, and design data are converted into a comprehensive, actionable materials list that drives the entire procurement and construction process. For asset-intensive industries, where the wrong valve or misidentified pipe can cause significant delays and safety risks, accuracy at this stage is paramount. The goal from a CAPEX or project perspective is to be able to collect the material requirements to understand material demands and trends that will define the procurement needs. The method for aggregating material requirements will differ depending on the strategy set forward in the Materials Management Plan, MMP. In CAPEX projects, materials are typically aggregated at the area or engineering work package EWP levels to maximize quantities during the requisition process. Within operations, this is typically done at the work order level to support maintenance activities. There are other supply chain strategies that will also come into play, which will be discussed in the next chapter. In the digital-first environment described in previous chapters, the process of gathering requirements is no longer a slow, manual handoff. Instead, it's a dynamic, integrated process where data flows seamlessly between design applications and enterprise systems. Establishing this digital foundation ensures that material requirements remain accurate, traceable, and aligned with both project execution and long-term operations. This chapter will outline the key aspects to consider for gathering material requirements. Materials management solutions. A core element for effective material requirements is to employ a materials management solution because relying on patchwork processes is a critical vulnerability. The old paradigm, where complex projects are managed with disparate spreadsheets, manual processes, and isolated data sources, creates a breeding ground for errors, delays, and financial risks. Each time data is manually transformed or re-entered, the risk of inconsistency and human error multiplies. What starts as a simple list of required materials in an engineering department morphs into a complex, unwieldy artifact by the time it reaches procurement, logistics, and the construction site. A modern, intentional materials management solution, however, replaces these disconnected activities with a cohesive and integrated process. By serving as a single central hub, it eliminates the need for complex, error-prone spreadsheet macros and manual data manipulation. Instead, it automates the flow of trusted data from design and engineering directly into all subsequent project activities, including vendor management, procurement, warehouse logistics, and long-term operations. The solution acts as the central nervous system for all project materials so that accurate and enriched material data is accessible to all stakeholders in real time and is consistently carried through every stage of the asset's lifecycle. This not only streamlines project execution, but also builds a robust, reliable data foundation for maintenance and operations well after project handover. To assess your own situation, look at the number of manual interventions and data re-entries required to get material information from design to procurement. Ask yourself, is your team spending more time wrangling data in spreadsheets than strategically planning for project success? In a spreadsheet-driven world, multiple versions of a single document often exist, leading to confusion and errors. Question whether your project team is truly operating from a single, reliable set of data or from a collection of siloed, disparate information sources. Consider also whether your material requirements process is built to support not only initial procurement, but also downstream activities such as spare parts inventory, warehousing, and long-term asset management. If it cannot make that transition smoothly, the result is often an expensive and unreliable handover to operations. Key questions to ask. Does your current process create transformation fatigue? How reliable is your single source of truth? Does your solution connect the full project lifecycle? BOM structure, PBS or FLOCS. The effectiveness of any robust, unified materials solution depends on a well-defined hierarchical structure such as a plant breakdown, structure PBS, or functional locations FLOCS. It is the fundamental framework that provides context and meaning to every material, asset, and activity throughout its life cycle. Without this intentional structure, a complex industrial facility is simply a random collection of components. With it, every part is clearly situated within its broader context, from its specific location in a system to its parent assembly, offering unprecedented traceability and operational intelligence. In practice, a well-implemented hierarchical structure acts as a bridge that provides a smooth, continuous flow of information from the initial engineering design phase all the way to ongoing maintenance and operations. For example, the engineering BOM is not a flat list of items, but a nested, parent-child structure that mirrors the physical assembly of the plant. By mapping this engineering data directly to a consistent PBS or FLOCS hierarchy, procurement can place orders for the correct materials, and construction crews can ensure they are delivered to the precise location for installation. This reduces material-related rework, mitigates safety risks associated with using incorrect parts, and accelerates project timelines by eliminating costly material mismatches and identification errors. Additionally, this hierarchical structure allows for data integrity and continuity at project handover. While projects focus on CAPEX for bulk items, operations prioritize the management of spare parts and long-term asset health. The PBS/FLOCS structure also allows for a seamless transition so that the rich data captured during design and construction is not lost, but is instead enhanced for use in maintenance, planning, and long-term asset reliability. Maintenance teams can use this structure to quickly trace a component's location and history, track maintenance costs at the asset level, and perform failure mode and effects analysis (FMEA) to preempt future issues. This transforms materials management from a reactive, project-specific task into a continuous data-driven engine for optimizing asset performance and lifecycle value. Key questions to ask. Does your asset hierarchy accurately reflect our physical assets and operational workflow? How effectively does your hierarchical structure support long-term operational goals? Is your asset hierarchy integrated and used consistently across engineering, procurement, and operations? Material collection. Once the hierarchical structure, PBS or FLOCS, has been established, the framework is set for the actual collection and loading of material requirements. This process transforms the raw data from engineering into the actionable intelligence required for downstream activities. This is a critical step of data validation and enrichment, where the BOM becomes the dynamic blueprint for procurement, warehousing, and construction. In a modern, integrated environment, the process moves beyond the static engineering BOM, EBOM, generated by design software. While EBOM provides the initial list of parts and quantities, a robust materials management solution supports the creation of several BOM types, including multi-level BOMS, which mirror the PBS/FLOCS hierarchy to show parent-child relationships and subassemblies. Manufacturing BOMS, which include additional details like packaging, consumables, and assembly instructions. Service BOMS, which are optimized for long-term maintenance and repair. A critical consideration at this stage is capturing additional attributes required to support integration and downstream activities. By ensuring all necessary attributes are attached to each material record at this early stage, it creates a comprehensive baseline for all subsequent project materials management activities, from supply chain and warehousing to construction and eventual operation. This proactive data enrichment minimizes late-stage scrambling for missing information, reduces costly procurement errors, and ensures seamless execution across the entire asset lifecycle. Key questions to ask. What type of BOM is required to support the business requirement? EBOM, MBOM, Service BOM, etc. How do you validate BOM data against the hierarchical structure and material master? Are you consistently capturing all necessary data attributes upfront? Suggested best practices. A BOM typically isn't that complex. There are some key elements that a BOM must have to start the supply chain process, including unique part number and commodity code, unique identifiers for each component. Quantity, the number of each part required. Unit of measure, defines how materials are counted. Description and specifications, provides clarity on components. Additional information can be added after loading into a materials management solution to provide additional context. ERP, definitions, e.g., classification and characteristics. Procurement, type, defines if parts are purchased or manufactured. Lead time and supplier. Details, helps with supply chain planning. Revision tracking. If controlled and contextualized information is an asset of the 21st century, then storing revision history is the crystal ball for organizations. Materials are subject to constant change driven by design iterations, engineering updates, and supply chain adjustments. In this dynamic environment, a disciplined approach to revision tracking is a strategic imperative. If a standardized taxonomy and hierarchical structure provide the foundation for consistent materials data, then revision tracking acts as the historical record that unlocks an organization's predictive and analytical capabilities. It moves materials management beyond the transactional to the strategic, transforming a project's history into a valuable dataset for future endeavors. This involves documenting what changed, when it changed, who approved the change, and the associated impact on linked documents and downstream processes. A robust revision strategy is essential for tying material requirement documents directly to their corresponding data. By capturing this granular history, an organization can build a comprehensive audit trail that is invaluable for compliance, root cause analysis, and dispute resolution. Over time, this historical data becomes a potent source of business intelligence. Consistent revision tracking allows for trend analysis across multiple projects, enabling engineers and planners to predict future material needs, anticipate cost fluctuations, and optimize inventory strategies. For example, by analyzing revision patterns on similar projects, an organization can identify recurring design issues, leading to proactive standardization and process improvements. This visibility reduces the risk of rework, streamlines workflows, and ultimately provides a significant competitive advantage by lowering project costs and accelerating execution. The ability to look back at the documented journey of a material from concept to operation is what provides the foresight to reduce waste, control costs, and build assets with greater efficiency and reliability. Key questions to ask. Are there current milestones or stages where history needs to be recorded? If so, how many and at what level does history need to be tracked? Is your revision tracking truly integrated, or are you manually matching data to documents? How effectively does your revision strategy ensure data continuity at project handover? Reporting and analytics. Once materials data is collected, standardized, and tracked within a modern materials management solution, it transforms from a static record into a dynamic, strategic asset. Effective reporting and analytics are the tools that harvest this rich data to drive tangible business value. A materials management solution that provides trusted data can move an organization beyond reactive problem-solving to proactive, data-driven decision-making. This insight allows stakeholders to produce more accurate forecast demands and mitigate the risks associated with duplicate, outdated, or missing information. Interactive dashboards and customizable reports can visualize KPIs like material usage rates, procurement cycle times, and inventory levels. This immediate access to information enables rapid identification of bottlenecks, potential delays, or emerging issues before they escalate into costly problems. For example, by analyzing historical usage patterns, organizations can predict which materials will be in high demand, allowing procurement to negotiate better pricing and ensure availability. Key questions to ask. What KPIs need to be tracked? Inventory, procurement cycles, etc. How will data be used for forecasting or planning? What additional data, for example, from Material Master, Will the BOMS need to support reporting needs? Thinking about the future, material requirements can cover a lot of different commodity types. The simplest would be to focus on bulk commodities for the largest discipline, that is, piping. No matter where you decide to start, it is important to understand the current state of materials requirements for that discipline. This involves a comprehensive review of existing processes, systems, and data quality to identify strengths, weaknesses, and key areas for improvement. Another key element is to establish cross-functional governance. An effective materials requirements process breaks down traditional silos, so it requires unified ownership and direction. As an organization masters that aspect, it's not unusual to expand the vision to optimize other project items or assemblies. Allow yourself and the organization to organically grow to meet the need. Look for continuous areas of improvement or new pain points. Don't stop asking what's next. The ReVisionz advantage. With decades of experience in asset-intensive industries, ReVisionz brings a deep understanding of operational realities to the table. We combine this domain knowledge with technical expertise to build scalable and resilient solutions that work in real-world environments. We don't focus on a single stage of materials management. Our approach encompasses the entire asset lifecycle, from the initial project phase, CAPEX, to long-term operations and maintenance, OPEX. This ensures continuity, prevents data gaps during project handover, and supports the asset's full lifespan. For companies stuck on their digital transformation journey, we provide a clear roadmap based on business capabilities rather than simply implementing new technology for its own sake. Our structured, incremental approach helps clients achieve measurable value while building a sustainable digital foundation. Continue your exploration of materials management by subscribing to our Digital Journey Notebook. And if your organization is seeking hands-on guidance, we're here to design an approach that meets your goals.